Hello, in this video I'm going to explain this exercise that we did in class that says that there's a lynx that's chasing a rabbit that is 30 meters away from it. So we can do a drawing like this one and we can place the lynx in here and the rabbit in here if we know that the distance is 30 meters. Okay, and then they tell us that the lynx is chasing the rabbit with a constant acceleration of 5 meters square second. So 5 meters square second is the acceleration of the lynx. And then we also know that the rabbit is trying to escape with a velocity of 4 meters per second with a constant velocity. So if the rabbit has a constant velocity, for the rabbit we can use the formulas of the uniform rectilinear movement. And if we know that the lynx has a constant acceleration, with the lynx we can use the formulas of accelerated movement. Okay, and then we know that the rabbit is trying to escape to find refuge 15 meters away. So the rabbit is running in this direction and the lynx is also running in this direction, chasing the rabbit. So how can we know if the lynx will catch the rabbit? So first we need to discover how much time is going to take the rabbit to cover this distance. And then we have to know how much time is going to take the lynx to cover this distance. And if the rabbit arrives first to the burrow, then the rabbit is going to win. Okay, so I'm going to use first this formula. If we know that the velocity of the rabbit is 4 meters per second and the distance is 15 meters, then I have to use the formula that says velocity equals distance over time. So if velocity is 4 and distance is 15, then I'm going to move the t to here and the 4 to underneath the 15. So 15 over 4 is 3.75 seconds. So this is how much time is going to take the rabbit to go from here to here. Is how much time is going to take the rabbit to cover 15 meters, 3.75 seconds. Okay, so now I have to do the same, but with the lynx. And for the lynx, I don't know the velocity. I know the acceleration. I know that the acceleration is 5 meters square second. And I know that the distance is 45 meters. Question, why do I use 45 meters and not 30 meters? Because if I use 30 meters, I'm going to discover how much time is going to take the lynx to arrive to this point. But the rabbit is also moving. So this means that when the lynx arrives to this point, the rabbit has already left. So I have to measure the time with all of this distance, which is 45 meters. And since the lynx has acceleration, I can use this formula, which is the formula for accelerated movement. So total distance 45, initial distance 0 because we start at the beginning. Initial velocity 0. Since they don't tell us the initial velocity of the lynx, we can assume that the lynx was at rest. And in here I multiplied by the time, then a half times acceleration, which is 5, and then a square time. Okay, so 45 equals, this is 0, 0, a half times 5 is 2.5, and then t squared. So since 2.5 is multiplying the time, I can pass 2.5 in here to the other side dividing. So 45 over 2.5 is 18. And now I have to do the square root of 18, which is 4.24 seconds. So the rabbit arrives to the house in 3.75 seconds. And the lynx needs more than 4 seconds to arrive to the house. So the rabbit arrives earlier, so it survives. Okay, let's do now this second exercise that says that there's a lion that is chasing a zebra with a constant acceleration of 3 meters square second, and the zebra is escaping with a constant velocity of 4 meters second. If we know that there's constant acceleration, we know that it is an accelerated movement. If we know that there's constant velocity, we know that there's an uniform movement. And then we also know that the zebra is 8 meters away from the lion. So we can do a drawing like this one. If the lion is in here and then there's 8 meters and now the zebra is in here. And we know that they're running in the same direction because the zebra is trying to escape and the lion is chasing the zebra. Okay, so again, the lion has an acceleration of 3 meters square second and the zebra has a velocity of 4 meters per second. If the question is how long, we need to discover the time. But the thing that we need to think here is that if they are running in this direction and the zebra is also running in this direction, they are probably going to meet in some point. So where they meet, this point we can call it x1 for the lion and x2 for the zebra, and this is going to be the same point. Okay, so for the lion, x1, this is going to be the one about the lion. We have to discover now how much is the initial position, because I'm going to use this formula: velocity, time, a half, acceleration, and then t squared. How do I know that I can use this formula? Because if we know that the lion has a constant acceleration, I can use the formulas of MRUA. Okay, so now x1 for the lion, the initial position is going to be 0, the initial velocity is going to be 0, and then there's the time. 1/2, the acceleration in this case is 3, and we don't know the time. Okay, I can simplify this formula a little bit more. I'm not going to put the zeros again. 0 times time is going to be 0, so I'm not going to put it again. 1/2 times 3 is going to be 1.5 t squared, and then I cannot do anything more because I don't know how much is the time, so I'm going to leave this formula like that. Okay, let's do now the same formula but for the zebra. So in the case of the zebra, I cannot use this formula because this is the one that I'm going to use if there's acceleration. In this case, there's no acceleration, so I'm going to use the formula that says initial position plus initial velocity times time. This is the formula of the MRU without acceleration. So for the zebra, how much is the initial position? In this case, it's not 0 because 0 it was for the lion, but the zebra is 8 meters away. So the initial position of the zebra is 8 plus how much is the velocity of the zebra? 4. And again, I don't know the time. So this is the formula that I have for the final distance of the zebra. So with these two formulas, if I know that they are the same, as we said before, x1 and x2 are the same. Why? Because when the lion finally catches the zebra, they're going to be in the same position. So I can place these two formulas together since we know that x1 and x2 are the same. And I can say that 1.5 t squared is going to be 8 plus 4t. So since this is a second degree equation, I can solve it like we normally do, like minus b square root of b squared minus 4 times a times c. All of this divided by 2a. Since this is time and time can only be positive, I'm going to stay just with the positive, okay? So t equals 4 plus square root of 64 over 3, only with the positive value. So time is 4 plus 8 over 3, which is 12 over 3, 4 seconds. So 4 seconds is how much time does the lion need to reach the zebra? 4 seconds, okay? And now, if I want to calculate how much distance will the lion need, these two that we did before are the formulas for the distance. And since I know that the time is 4 seconds, I can use either one of these formulas. It doesn't matter if I use this one or this one, because I'm going to get the same value. So I can say that x is equal to 8 plus 4t, which in this case is 4, so 4 times 4, and all of this is going to be 8 plus 16, which is 24 meters. So 24 meters is the distance that the lion needs to catch the zebra. If you want, you can try it with this other formula, 1.5 times t squared, so 1.5 times 4 squared, which is 1.5 times 16, which is as well 24 meters. The same result. So it doesn't matter which one of the two formulas you use. You can use either this one or this one. So this could be A and this could be B, the distance and the time. Okay, let's do now this exercise, which is another one of the trains. We know that there's a train that departs from Barcelona, and then there's another train that departs from Paris. And the train from Barcelona leaves at 10 a.m. and the train from Paris leaves at 10:16 a.m. So it leaves 16 minutes later. And we know that the distance between the two cities is 1,200 kilometers. And we also know that the train from Barcelona leaves with a constant velocity of 100 kilometers per hour, and we know that the train from Paris, it leaves with a constant velocity of 120 kilometers per hour. Remember that when we have these problems and they are moving in opposite directions, we're going to put the second velocity negative, okay? Because they are going in opposite directions. So in all of these, we know that there's constant velocity and then again constant velocity. So for this problem, we're going to use the formulas of uniform rectilinear movement. In this case, there's no acceleration. So we're going to use the formula that says x equals x0 plus velocity times the time. But the problem in this exercise is that the trains don't leave at the same time, because this one leaves 70 minutes later. So we need to analyze first where's the train from Barcelona 70 minutes later, okay? This is Barcelona and this is Paris. Okay, so first, where is the train from Barcelona 70 minutes later? To know this, I can pass first the 70 minutes to hours, because since I have this velocity in kilometers per hour, then I have the distance in kilometers. It's better if I have the time instead of in minutes. It's better if I have the time in hours, like this one, okay? So I'm going to pass this 70 minutes to hours. How? I can use conversion factors, I can do it mentally, you can only divide, wherever is better for you. So if we divide this, we're going to get 0.28 hours. So this means that 70 minutes is the same as 0.28 hours. And now I have to discover where is the train of Barcelona 0.28 hours later. So since we know the velocity and we know the time, so velocity velocity is 100, and then the time it is 0.28, and I know the formula that says velocity equals distance over time. I can do distance equals velocity times time. So distance equals 100 times 0.28, which is 28 kilometers. How do I know that I'm going to get this result in kilometers? Because the velocity is in kilometers per hour. Okay, so now I know that at 10:17 the train from Barcelona is not here, now it's in here, okay, at 28 kilometers. So we can say that this is 28 kilometers. And it is the position of the train of Barcelona right now at 10:17. The train from Barcelona is in here. So now I'm going to use this formula like we mentioned before, okay? So x1 is going to be for the train from Barcelona. So the initial position of the train from Barcelona is 28. The velocity is 100, and I'm going to multiply it by the time. And now I'm going to do the same, but for the train from Paris. So if this position is 28, then this one is 1,200 kilometers. So the initial position of the train from Paris is 1,200 kilometers. And now minus the velocity, which is, as we saw before, 120 t. Remember to write this negative because they go in opposite direction. This negative is the one that we got in here, okay? Negative velocity. And now, since I have these two formulas and I know they're going to meet in the same point, probably in the middle or more or less, since the train from Paris is going a little bit faster, it's going to be more close to Barcelona than Paris, okay? So I'm going to say now that x1 is equal to x2, y? The same thing that in the previous exercise, because I know they're going to meet in the same point. So 28 and 100t is equal to 1,200 minus 120 time. So I'm going to move all of this to the other side, and I'm going to place the t's together. So 100t plus 120t equals 1,200 minus 28. All of this is 220t equals 1,172. And now to leave the t alone, I have to pass 220 dividing. So this is 5.3 hours. So this is how long it's going to take the two trains to meet. And the question is, they're not asking me the time, that they're asking me at what distance from Barcelona. So I'm going to use now these formulas to discover the distance. Again, I can use either one of these two. So x1 is equal to 28 plus 100 times 5.3. So the final result is 560 kilometers.
From Barcelona.